Find the equation of a function that results from shifting this left by 4 units, stretching it vertically by a factor of 3, and reflecting it across the x-axis. Oh boy, so we got a lot going on here. So we start with f of x equals x squared. We want to shift it left by 4 units. That's the negative x direction, which means we're going to have to add 4 inside the function. So it will become f of x plus 4. Then we want to stretch it vertically by a factor of 3. So we just multiply the whole thing by 3. 3f of x plus 4 equals 3x plus 4 squared. And then finally, we want to reflect it across the x-axis, which means we're flipping it upside down. So it will become negative 3f x plus 4 equals negative 3 times x plus 4 squared. Now I want to just do a little bit of extra work here because I want to show you something. If we expand the right-hand side here, we get negative 3 times x squared plus 8x plus 16, or in other words, negative 3x squared minus 24x minus 48. Okay, let's have a look at something. F of x equals x squared. Now, what I want to graph next is negative 3x squared minus 24x minus 48. So here we have the function. It's being shifted to the left by 4 units. It's being flipped upside down and stretched by a factor of 3. If I say negative 3 f of x plus 4, notice that this is exactly the same as the one we just drew. The reason I'm showing you this is I want to make it clear that what I've done on the left-hand side, where I've applied the transformations in function notation, is exactly the same as what I've done on the right-hand side, where I've done the transformations, I've expanded the brackets, collected like terms, simplified everything. So the key thing here is to understand this is what the question's looking for. This is your answer. You could get away with leaving it in this form, but I also want you to understand how I've done it on the left-hand side here. I want you to be able to read this just as easily as you can read this. They're very similar if you think about it.